Hello, we will now do a nice little review of chapter 3, and which deals with regression, primarily linear regression. And so let's look at this problem. So it says the number of hours that a salesperson spends on sales calls in a week and the corresponding profit that the salesperson makes for that week in hundreds of dollars are shown below. Describe the relationship between the two variables. Remember to describe the direction, outliers, form, and strengths. That's the DOFS deal. And the first thing about regression is that it has to be categorical. It has to be quantitative variables. And these certainly are. And the data is paired. This number goes with that one. That one goes with that one. And so when he did sales calls for 5.1 hours, he made $3.700 or $370. And so it asks us to describe the relationship. So the first thing you have to do is make a scatter plot. In other words, graph these in essence, XY coordinates. So that's what I've done there. You just graph 3.6 and 1.2. So that's 3.6 and 1.2, and then graph 4.7 and 1.7. So 4.7 and 1.7. So it's just plot those points just like you did back in algebra. Make sure and label the axes, both of them, and scale both of the axes. And so there you go. So that's plotted, and you'll note that there's definitely a positive relationship. It goes up from left to right in general, and it would be linear and strong. And so that's what I said here. There's a positive, linear, and very strong relationship, and mention the variables, mention the context between the number of hours and the profit. And there appear to be no outliers. Outliers would be way above or way below the pattern of the other points. And so that's how you do that. So then number 2, it says find the correlation coefficient and the equation of the least squared regression line. And so we could do these by hand, but you don't have to do them by hand. You can use your calculator. And so this is how you use your calculator to do that. So first of all, I'm going to put these values in list 1 and list 2. And so the way you do that is by hitting the stat button and then hitting enter on edit. And then I've already entered these. And so in list 1, I put the number of hours, and in list 2, I put the profit. So you do that. And so then to come up with your R value, your correlation coefficient, and the equation of the least squared regression line, you're going to do this command. You're going to go stat and then arrow over to calculate, and then go down to the 8th option right there, linear regression A plus BX. And so you hit enter on that. And so my X list, I put that in list 1. Okay, if it didn't say list 1 there, you'd hit second the 1 button, and then list 2 is right above the 2 button. So if it didn't say list 2 there, you just go second and hit the 2 button right there. Frequency list, leave it blank or have a 1 there. Okay, that's important. Okay, if it has something else there, it's going to do it wrong. Store regression equation in Y1. And there's a couple of different ways you can put Y1 there. You can't hit the vars button. So go vars and then arrow to Y vars and then hit enter, enter. Vars, Y vars, enter, enter, and it puts Y1 there. Or you could, many calculators have a shortcut by going to F4. So if you hit alpha trace, which is F4, and then you just hit enter on Y1, right like that, boom. And so there you notice, so there's the form of the line, A plus BX, there's A and B, that's my y-intercept, and that's my slope. There's R squared, and there's R. Now, if your R squared and R do not appear there, it means your diagnostics isn't turned on. So the way you turn that on, if your R's don't appear, is just go to mode and scroll down to stats diagnostics and make sure and turn them on. Okay, so that's all there is to that. And so anyway, by the way, some calculators, when you do the command, it immediately takes you to this field. And so if that's the case, just hit L1, L2, Y1 like that. And so there we go. So there's my regression information. And so my R, my correlation coefficient is 0.9482 approximately. And then there's the equation of my line. Y is equal to negative 1.581 plus B, which is 0.87275 times X. And so this is the way I wrote that down. Make sure and define. So there's R, the correlation coefficient. And so make sure and define your X and Y. That's very important. You'd get partially correct if you didn't define your X and Y, and make sure and put a hat on the Y. You get partially correct for this whole thing, just for not having a hat on your Y, or you could say the word predicted. What that hat is saying is that this equation is creating predicted Y. So you could say write out predicted Y, but it's easier to put a hat on it. And so there you go. So that's number 2. Number 3, how much profit do you expect to make if he does 10 hours of sales calls? And then by doing this calculation, what did you just do? Well, by 10 hours of sales call, you just plug 10 into the equation that you just made. That's the whole purpose of this equation, is to make predictions. So if we make 10 hours of calls, we're predicting that it comes out 6.69, but it's not $6.69 because this thing is in hundreds of dollars times 100. Make sure you pay very close attention to the units. This profit is in hundreds of dollars. And so this predictor equation is going to produce hundreds of dollars. In other words, you got to multiply it by 100. Okay. So we predict this is the prediction. We don't know how much exactly it's going to be, but this is predicting $669.413. And it asks, what did you just do by doing this? This is an extrapolation because I plugged in a value for X that's outside of my domain of X's. Anything you plug in that's below 3.6 or above 9.2, anything that's above that or below that is an extrapolation, and it should be viewed with caution. So this is an extrapolation, and should be viewed with caution. Because there could be other factors that the model starts obeying once you get outside of these X values. So, okay, so that's number 3. Number 4, for each increase in 1 hour of sales calls, what change in profit do you expect? In other words, every time X goes up by 1, what are you expecting to happen to Y? That is the slope. That is this thing, the coefficient of X. That's what the slope is. So the answer to number 4 is just B. It's just the slope. That's 0.82751. That's probably the most asked question in linear regression. And most of the time, what the way they'll ask it, they'll ask you to interpret the slope. And to interpret the slope, you would just say that. You would say, well, to interpret the slope for each increase in X of 1, and which in this case is the hours of the sales calls of 1, we predict that the Y, that the profit amount is going to go up by $0.82751. So anyway, okay. Number 5, if he makes 0 hours in sales calls, all right, what profit do you expect him to get? That's what the y-intercept is. The y-intercept is what you predict y is going to be when X is 0. So the answer to 5 is just the y-intercept. Okay, it's just the constant there. It's A. So that's all there is to number 5. Okay, number 6. What percent of the change in profit is explained by the change in the number of hours of sales calls? That's what R squared is. It's the percent of the change in Y that can be explained by the change in X. Or another way you'll see it worded as is the percent of the change in Y that can be explained by this model relating X, Y and X. So and in this, so R squared, you can get that off of your calculator. And so it's just that right there. It's 0.89906. And so that is just asking for R squared, and it asks you for a percent. So I'll put it in percent. So that's the answer to 6. Number 7, calculate the residual of when there's 4.7 sales calls. When there's 4.7 sales calls, that's this point where our X is 4.7 and our Y is 1.7 in profit. Okay. And so the residual is equal to the actual Y minus the predicted Y. It is how far above or below the line our point is. And so the actual Y value that goes with this point is 1.7. Just right there. There's the Y value that goes with it. The predicted Y is what you get when you plug 4.7 into the equation, into our least squared regression equation, which is this thing. So I'm just going to plug 4.7 in there, and that'll give me the predicted value, which in this case, it ends up being 2.3083. Okay. And so I say 1.7 minus that, and it gives me that. And so there you go. Now, by the way, a quick way to enter in 4.7, because I have this equation stored in Y1 in the calculator. So if you wanted to, you could just call it Y1 to do that quickly. So if I hit alpha F4 and call it Y1, and then just hit open parentheses 4.7, that'll enter 4.7 to that equation, and it gives me the predicted Y value right like that. And so that's the predicted Y. And then you take the actual Y and subtract it, and you got yourself a residual. Also, another thing you could do to get the residuals, your calculator calculates the residuals automatically for you. So if you want to look at them, you could copy them to a list. So I'm going to copy them into list 3. I'm going to do stat and edit, and I'm going to highlight the top of list 3 like that. And then I'm just going to go to the list menu, go to second list and scroll down to resid, and that's where all the residuals are that were created when I did the linear regression command. And so, and you'll notice there's the residual. So the residuals for this point is that. And so that's telling me that point is negative 0.608 below the line slightly over predicted for it. So yeah, so there you go. So that is that. And so that's the residual. Now, and then the most frequent way that regression data is going to be given to you in the AP Stats exam is by a computer printout. So you got to be able to read one of these. So this one says a regression analysis of the number of customers a store has and the number of bags the store uses that day. All right. The computer printout of the regression is shown below. All right. And so now, so what they've done is they have done a study of the relationship between the number of customers that a store uses and the number of bags that the store uses. And you would certainly think that the more customers they have, the more bags they would end up using. And so what this means is, so coefficient of constant, that's your A, that's your y-intercept. And then your X variable is always there. That your explanatory variable is always going to be listed there. It's the number of customers. The coefficient of X in a linear equation, that's the slope. So that's B. That's A, that's B. We're not going to use these numbers over here. We're going to use these when we do chapter 12, but we're not using them now. But there's R squared. We'll never use R squared adjusted. It's these four numbers you have to know how to use in this semester that is very important. There's S and there's R squared. What are the explanatory and response variables? Well, the explanatory variable is just the number of customers, our X variable, and the response variable is the number of bags used. And so there you go. How many bags would you expect to sort of use? There are 20 customers. So we just want to plug 20 into our X. And so that's what I did. So there's the equation right there. So remember, there's your y-intercept, there's your A, and there's your B, that's your slope, right? And then I just plug 20 in for X. And so, and that gives me that 65.81 bags. So that's my prediction if there's 20 customers. All right. Describe S, the standard error about the line. And that's what that number is. That is the average of the residuals in essence. It's the standard deviation of the residuals in essence, but it's the average amount predictions with this model will be off. And so like when we look at this, we try to make a prediction about, hey, if we have 20 customers, how many bags we're going to use? Well, this is telling us how off this model is on average. So really, we're predicting about 66 bags, but we wouldn't be shocked if we needed like 68. Okay, that would be, one standard deviation above the mean effectively. But anyway, and so what S is, it's the average amount of predictions will be off. And so we'll say that predicted number of bags used by this model will be off by 1.87 on average. Okay, that's what it is. So there you go. Number 10, when there are 30 customers, the residual is 3.6. How many bags were used that day? Okay, well, we'll use the formula for residuals. The residual is equal to actual Y minus predicted. Okay, so there's the residual. Actual is what we're trying to find. And the predicted Y is what you get when you plug your X into the equation, which our X is 30 here. And so we just solve this for A and we get 100.91. And so that was, and so, and in this case, if it asked it in such a way that, you had to pick an integer, then you pick 101. You just round to the nearest integer. Number 11. All right. And so these two deal with section 3.3, all right, which deal with transformations, which deal with exponential data and power law. And here's the two main things you really need to know from that section. Number one, if the data is following an exponential model, in other words, it follows a model like y is equal to a times b to the x, where x is an exponent and a or b are constants. Okay. What can be done to straighten the data? In other words, if you look at your scatter plot and it's doing something like this, like that, it's showing a noticeable curve. What could you do to straighten that? Because if you could straighten it, then you can do all this other stuff we've been doing to create, least squared regression equation and make good predictions. But we've got to be able to straighten it. And if it's exponential, the way you straighten it is by taking the log of the y values. In other words, just taking your x value and the log of the y's. You could do log base 10 like that, or you could do the natural log, the ln, the log base e. Either one of those will work, or log any base you want. And then what if it's following a power law? Well, a power law where x is the base, okay, and it's being taken to a power, okay, like y is equal to x squared or something like that. What can be done to straighten it? Following the power law, you can take the logarithm of both the x's and y's. just like that, or you can do it with LN. And so there you go. And so that's a little quick rundown of chapter 3. If you have any questions about anything in regards to that, please let me know. And thanks for watching the video.